January 2014, Core 1, Question 1. The shape of the graph will remain constant and the function will tell us what translation to apply to the coordinates. So look at P, which is at 3, 1. This one we want to take the y coordinate and take away 1. So P is going to move to 3, 0. So if I put that onto a set of axes, then that's my point P. This second transformation is happening to the x coordinates, and we always do the reverse. So we're going to add 2 to the x coordinates, which means that P is going to go to 5, 1. Nothing has happened to the y coordinates. So 5 and 1, and always make sure it's really clear for the examiner where your transform point is. Again, we're dealing with the x coordinates, and this time we're going to divide them by 3, which means that P is at the point 1, 1. So P will be at the point 1, 1. To simplify as far as possible, the first thing I'm going to do is expand the brackets. So 1 minus root 2 all squared is 1 minus root 2 upon 1 minus root 2. It's quite useful sometimes to use the grid method for surds, and this gives us a 1, a minus root 2, minus root 2, and a plus 2. So that becomes 3 minus 2 root 2. So my fraction is now 3 minus 2 root 2 all over 2 plus root 2, and I must now rationalise the denominator because we're not allowed this surd in the denominator, and that means I'm going to multiply top and bottom by 2 minus root 2. Again on the top I'm going to use my grid method, so I have 2 minus root 2 and 3 minus 2 root 2. 3 times 2 is 6. 3 times root 2, 3 root 2, 2 times 2 root 2, and the square root of 2 times square root of 2 is going to be 2, 2 times 2 is 4, and the 2 minuses make a plus. So that gives me on the top line 10 minus 7 root 2, and on the bottom I have the difference of 2 squares, so 2 squared, which is 4, take away the square root of 2 squared, which is 2. So I have 10 minus 7 root 2 all over 2, and it is important here that the line for the fraction is under all of the numerator.